Home ownership is a project every single day for the rest of your life. That's basically what I would advise anyone who's looking to buy their own home. So Project Homestead here, update. I have crawl space access under the pool deck back there. And because it has been not really well designed, only part of it was vapor barriered. So the next project's coming up. I am doing some mold treatment for the wood. There's barely any on it, but I figure if I mitigate that first and then encapsulate the crawl space, that will be my next project. But that's a little bit further down the road. The next big project, because there always is 2 or 3 at a time, just finished the lighting in here, and now I can finally use my workspace. But I just got my workspace back right at the beginning of summer here in southeastern North Carolina, and it gets hot real fast. This is, I think, 7:30 in the morning right now, and the interior temperature here, this is from my childhood. I used to put this on my ski coat. This is from Shawnee Peak in Maine. It's almost 80 degrees in here right now. And if you wanted to know the wind chill, which there isn't any, this has that too. Pretty cool, but I've had that since I was a little kid. I bought it at the Shawnee Peak novelty ski shop there. But needless to say, this space gets really warm. And when the truck's in there, it gets even warmer. And this is directly under that finished room over the garage, which is upstairs. I already had one of my AC units. I have two 2-ton AC units, so we'll actually talk about what that is real quick. I got some cardboard I got to burn over here, but this Lennox system is garbage. It's already pretty much dead. This original one, which is an R22, which is also 2-ton, this is the downstairs unit, and this one's actually still working really well. This one's harder to see the label on, but if you look here, on this sticker here, this serial number, that 024, that 24 is 2400 BTU, and every 12,000 BTUs is a ton. So that's how you tell how big your air unit is. But this one sucks. I had it priced out for how much it would cost to replace it, and even just having a individual do it, which was just this unit and just the air handler inside, was about $7,000, which I will eventually do, but right now I thought that's kind of crazy, especially since it's just going to eat a ton of power and continue to make my power bill about $500 to $600 a month because I have time of use power here in the South. So, and that's Brunswick Electric, and we'll go into all sorts of details about dealing with coding and zoning and all of the things that I've dealt with our county office, which the county office in Brunswick is awesome. Brunswick Electric is less than favorable because of some of the limitations that they impose. But what I'm trying to get at is the next big project. You'll see here, I have a wall mounting bracket for a ductless mini split condensing unit. This is to hold it up off the ground. This is the PVC line cover kit. So this covers the lines, and the lines are not only the electric, but they're the refrigerant lines. So that 410A that runs through these, and the electric that would also go with it. And what I plan to do is have 2 of those units in the house. So that upstairs unit was not doing well. So I got a 1-ton window unit. Just in the meantime, I had them recharge that, but it constantly bleeds out. So it has a leak, and I don't want to keep doing that because it's obviously not environmentally friendly. So I just put one of these in. It does an okay job. That's a really interesting unit because of the way that it's designed. It makes it so that, and I do have to pressure wash the upper part of the house yet. I haven't done that yet. But the notch out of that unit makes it almost like a mini split. It's an interior-exterior function, unlike a traditional window unit, which the whole unit opens the window. This has a small pass-through gap for those. But my goal will be to put at the very top over those windows in that finished room over garage, which is a fairly large room, an AC mini split. And it won't be just any mini split. It is a specific mini split that runs off of AC 210, and this is a 210 unit only because, and that's 210 volts, because it is the 2400 BTU or 2-ton AC unit. So it will be the exact equivalent cooling capacity of the unit that's already there, but it will be a ductless mini split, and I'll run the line set with those white covers down to here. I'll run the AC there. These are AC/DC units, and that is really important because you can run them off of solar power at the same time as AC, and that will allow you to have, which I will, a solar array that will be up here, and that solar array will feed both mini splits. This will be about 7 kilowatts that I can fit on this side of this roof, and that will feed into both, which is way overpowered, but that's obviously the intent. So the intent is to overpower it. I'll have one unit down here, ground level, and one that's wall mounted right above it, and I'll probably push them that way. I already have DC or AC 210 wired out here, a 30 amp and a 50 amp service. So I'll actually connect those to the units first, and then I'll run my DC once I mount the solar. But that will allow me to cool the complete upstairs of the house, and then add this, which is roughly 1,000 square feet of garage, to have its own unit, which I'll put up here. So I'll have to move some stuff around. I'll probably put it up top over there. I'd considered it over here, but I haven't really decided where it'll be, but it'll probably be over there just for the ease of running the piping for the line sets. But needless to say, I just got the stuff to do this right, which is to make it nice and trim and clean, and it'll also have a nice wall bracket, so it'll be mounted to the wall. I've considered doing the rack mount, so there's like a table section, and then it mounts to the ground, the other unit goes underneath it. I'm not really sold on that because I think they kind of look ugly, but I haven't really decided yet. But at the end of the day, this is the back of the house, my old Jeep, which I'll eventually be selling this, I think, which is the saddest thing I've ever come to conclude. I just don't use it enough. I love my truck now, so this thing just doesn't get enough love. But those two units will go there, and then they'll just kind of pipe up to the upper one, and then the second unit will be right about that height, roughly at the top of that window. But that will allow me to not only expand the habitable square footage of the house, which I'm never going to sell this house, so it doesn't really matter, but it'll add 1,000 square feet to the house, and it will add AC to the upstairs, and I'll be able to run the majority of what I want to cool directly from DC, so photovoltaic solar panels that will be on this. Along with that, I'm in the middle of planning, and this is unfavorable directional roofs, but it's also interesting because sometimes you can make lemonade with the lemons that you're given. South is directly this fascia of this building. So that side is east and that side is west. It's a little bit off kilter, but it's roughly about that. But because this roof is relatively flat, and I could only get the solar tax credits through the federal government once annually, my plan is, and I've already spec'd it out, this entire roof I'll be able to do basically 20 solar panels on the low side, 20 on the top side, and then the exact same on the opposite. So this will have 80 350 watt solar panels on it. And then I've been using the original tack room. So there's a room in this barn that is, before you even get into the stalls and everything, which we use grain, the old refrigerator that was in the barn. This is actually really climate controlled room. This room stays stable in a temperature, which is really nice. But this is where all the tack stuff was. It has a little desk and everything in here. This room, I'd actually just stored my wood in because it's also really nice, and my bee equipment and some other equipment that I had. But I'm actually gonna gut this room out. This is going to be where I put all of my inverters so that I can have indoor units exclusively. I'm gonna put fire barrier material on the walls, so this will be up to code. But I'll have 3 18 kilowatt inverters and 120 amp hours worth, or 120K amp hours worth of battery. So my goal will be, is that once that solar is feeding into, from the barn, feeding into the battery bank in this barn, it will completely be able to run my house on the peak days of summer, with probably, I would assume, maybe 2 days of autonomy at absolute most, if it were really, really cloudy. But the goal isn't for that. It's for the rest of the year, where I use 1/3 of that power. Most of the power in this house is actually used by the HVAC. And that's why I'm looking at putting 7 kilowatts on that side of the roof and 7 kilowatts on this side. Again, east facing and west facing. And that will take another 2 units that I can put from this side. One, I'm actually going to plumb into the crawl space instead of getting a dehumidifier, and I'll just air condition the crawl space, as well as, you can't go in the barn, get out of there. Come on, Atlas, come on, Luna, come on. I left this door open, come on. but the crawl space and then the downstairs of the house, which is also a 2-ton unit. And that would make it so that I can remove the majority of the cooling needs for the house and put it completely direct DC. So those are non-inverted in the way that you need a charge controller and an inverter for most solar. You can directly connect into those mini splits a MC4 connector for solar. So then the barn, what will happen is this will all become a backup generator for the house. And it's specifically, linguistically, that I will trench over to the house, and over at the main panel, I will put in a transfer switch that would work such that if the grid went down, the house could run completely off of the solar and battery backup from the barn. But what I'll do is I'll go throw the main breaker at the house to force that trip, and it will then take over from here. And the reason for that is where I live, we have a electric co-op, and they have made some really terrible rules about the way that they regulate the amount of residential solar you can have. The maximum you're allowed to have here in Brunswick County, North Carolina, under Brunswick Electric. So if you're under Duke Energy, I think it's 20 kilowatts that you're allowed to have, or 25 kilowatts. In Brunswick Electric Membership Co-op, BEMC, you can only have 10 kilowatts. And that's really not enough for even a fairly small house. So having a little bit bigger house and a farm that I need to be able to have AC and all of the other things for, that amount of capacity wasn't enough. And when I reached out to them, there was no way to circumvent that. There was no way to just isolate a subset of the grid or of my array to feed back to them. So I said, you know what I can do is make a backup generator, and then you get no power from me. And I even tried to offer them that anything that I overproduced, I would give them for free, no net metering. They could just have it and resell it, and I don't have any contract of return value. They wouldn't comply with that because they do impose these limits such that they make enough money off of all of the people who are on the utility to maintain the grid, which I'm totally all for that, because it's a form of like kind of communitizing the idea, or kind of breaking down the price of the cost of ownership across all of the members. But in order to have me participate, I can only give back a small amount. So what I'm now having to do is shut off my power completely, and then I don't participate at all, which is terrible. But at the end of the day, this will be a massive solar array. There's going to be 7 kilowatts there, 7 kilowatts there, and roughly 30 up here. So I'm gonna have, by the end of this summer, roughly 48 kilowatts of PV, or photovoltaic or solar, installed between these infrastructures. Those two will not be inverted. Those will be direct to air handler. And that will keep my crawl space. That's why we started the video with that. I want to make sure that that's dehumidified and cooled, because that's the first place of the house where you lose a little bit anyway. I want one downstairs and then one upstairs, and then expanded the space that's cooled into the garage. Then this will have to do less work, because the majority of your power, like I said, about 30% of your power bill is roughly just your HVAC anyway. So this, what will be the battery backup from the barn, won't have to do as much work, but I should have roughly 2 days of autonomy on the peak days of summer, which again, you got to expect your solar absorption at that point is much higher. So it might even be a little bit longer than that. But in the winter months, I'll probably have about 6 days of autonomy with that battery backup. And the battery backup, as well as the solar, is all part of a system that I will commission this calendar year, which means I'll be able to apply for the federal tax credit, which is 30% of the total cost of the system, which, based on a couple of extra factors that I've kind of worked into this, I should be able to pay this specific system off within a 3-year spread. Most people will be in the 6-year spread. But that being said, it's still a great way to basically be non-grid dependent. So I can be off grid, but also still have a switch to turn the grid back on. If my batteries die, if the solar breaks, if something goes wrong, I can literally just go switch the main breaker by the service panel, and I will then have power again. So at the end of the day, I'm trying to be off-grid, although I'm not allowed to in this county. It will be as close as I can personally get, because solar is the way to go. if you can afford it and if you have the square footage of roof infrastructure for it. I did consider building some ground mounts, but from zoning and permitting, that gets a little bit more tricky. If you're using existing infrastructure to mount it on, it's actually really easy. You just have to have an engineering stamp to make sure that the building's weight load rating for the rafter spacing is sufficient for the load that you're putting on it, and that the mounting plates, and this is again for southeastern North Carolina, I'm on a certain side of the highway, which means I'm closer to the ocean. So I have to meet 130-mile-an-hour wind load ratings for the solar panels as they're mounted to the roof. So that dictates the spacing between the mounting plates. But I'm going to get all of this material. I'm going to show you every step of the process, and I'm going to make sure that if you have any questions that I'm going in the comments and answering it. My goal is to do this massive scale off-grid system completely by myself with no other assistance. I'm going to use my tractor, my forks on my tractor. I'm going to build some little scaffolding to get all my materials up here. This is a really shallow pitched roof, so it's really easy for me to get up there and do this work, and it's not very high, so even if I fell off this, I'm not going to really hurt myself. I mean, I will, but not that bad. But I'll be very safe. I'll make sure I do everything by code and make sure that it's electrically compliant. The only part that I will actually have a neighbor who is down at the end of my road who is an electrician. I'll make sure he's there for every step of the process so that when I get my final electrical inspection, I can be sure that it will be commissioned in this year and that the county will be happy with it, and I can just throw the switch and be off-grid effectively. So I'll take you guys along for the journey, but I wanted to just give you the update of those are the big projects coming down the way for the farm here in the middle of nowhere.